This is the Microsoft Cloud Show, episode 161, where today we're going to talk to Kelsey Hightower about Kubernetes, recorded live October the 4th, 2016. Welcome to the Microsoft Cloud Show, the only place to stay up to date on everything going on in the Microsoft Cloud world, including Microsoft Azure, Office 365, SharePoint, the competitive landscape, and related technologies. Just the information. No marketing, no BS. I'm Chris Johnson.
And I'm Andrew Connell.
Send us a tweet either to the show at MS Cloud Show or to Chris at LoungeflyZ.
Or to Andrew at Andrew Connell.
As we'd love to connect with you. We're just two dudes telling you how we see it. The Microsoft Cloud Show is sponsored by Valid.nl. Valid is a Microsoft Gold partner whose mission is to enable its customers to excel in their business through the innovative use of technology. Valid is always on the lookout for consultants, architects, and engineers. Do you know Azure, BI, and Analytics, .NET, Office 365, or SharePoint? Look them up on Valid.nl. Good morning, AC.
Good morning, CJ. How's it going?
Good, mate. How are you?
Challenging morning.
Yeah.
This is by far the most interesting way that we've started recording, I think, in a long time, where just right before we started doing this, I lost my internet. So now we're both recording locally and talking to each other over the phone and hoping the recording picks up just fine. So
yeah.
Great way to start the day.
Yeah, nice. Well, it's heaving with rain here in Seattle, so I may lose my power or internet at any point.
Hey, speaking of that, since the last time we were together, I know we said that this was recorded live on October the 4th, but we recorded 2 interviews and we're doing the pre-show parts to them much later. Was it like October the 14th today? But since this, you guys are dealing with a storm now and a bunch of weather. We did the exact same. We were, last weekend, this time last week, I was in the midst of Hurricane Matthew bearing down on where I live. And it was one heck of an experience, man. Heck of an experience.
Yeah, not in a good way, I suspect. So I'm glad you guys made it through.
Yeah, that thing was rolling in, and it rolled in on a Friday, and on Thursday afternoon, they had ordered evacuations for the beach and everything. I live in an area called kind of right between St. Augustine and Jacksonville, Florida, and St. Augustine got hit really bad, but on Thursday morning, it was going to be a Category 3 hurricane, which is I think 130 mile an hour sustained winds. And they called for an evacuation for up to 3 different zones across the beaches in the city. We weren't in an evacuation zone, so we were just all locked up and had everything from outside been pulled inside and a bunch of food and water, expecting the worst and stuff. And so I think on Thursday at around like 2 or 3 o'clock, my wife and I had talked and said, we're not going to evacuate. We're fine. And at around 2 o'clock, the next hurricane update came out. For those of you who've never been through this, when they show the pressure drops and then it comes, usually the next update that comes out, the storm gets a lot stronger. So the pressure dropped again at 2 o'clock in the afternoon. And I talked to a bunch of people, even talking to you, and people were saying, are you going to evacuate? And I was like, no, we should be okay where we are. And one of the things I was using, or one of the lines I was using was that, hey, look, the weatherman for one of the local weather stations lives in my neighborhood, and his wife and 3 daughters are not evacuating. They're fine. So if they're staying, then I figure we're okay. Well, at around probably 3:30, she posts on Facebook or in texts us or something and says, update, we're getting out of here. It's getting worse. And at the same time, I talked to a neighbor of ours that has somebody that works with the Federal Emergency Management Agency, the FEMA, who said that it was going to be a Category 5, which is like 400% or something like 200 to 400% stronger than a Category 3. So it was all of a sudden like a pucker up moment. You got to get the hell out of here. And and so it's like my wife comes running upstairs to my office, and we're like, we're getting the hell out of here. And so it was a very exhausting Thursday afternoon. Long story slightly shorter, it did not get to be a Category 5. It ended up being a Category 3, and but it's still nuts, man. I tell you, it's really depressing seeing the place where you grow up and spend your entire life just get so many places just completely destroyed, other ones just so badly damaged and stuff. So it was the day of the storm was quite a depressing day, but all good. Everybody's getting back to normal and everybody's rebuilding. So it'll be everything will come back just fine.
Yeah, well, I'm glad to hear it, obviously.
Yeah.
Nice. So today on the show, we've got some news to get through before we get into an interview with Kelsey Hightower about Kubernetes. So you want to kick things off with a little bit of news?
Absolutely. Yeah, we can definitely do that. So the first bit of news here that I have is going to come from the Azure AD guys. They've got and I think that you've even got some news on for some Azure AD stuff as well, that they announced that the Azure AD Premium P2 option has gone generally available. And what this is that this includes a bunch of new offerings. This became available in the middle of September. It includes all the same things that you got in the P1 offering, but it includes two new things or two additional pieces as well. That's the identity protection and the privileged identity management capabilities, which are two really important enterprise-based features to give customers a much better control and be able to manage their users and protect their identities inside of organizations. We all know that that's been a big deal with all the different hacks and stuff that we've been seeing in the news over the last few months.
Yeah, for sure.
How about you? You have any Azure AD news for us?
I do. Azure Active Directory Domain Services has gone GA. So this has been in preview a little while, since I guess late last year sometime. And apparently they've gone into general availability now. So what ADDS for short is Azure Directory Domain Services is effectively a domain controller in the cloud. You know, if you've got AD machines running on premises and you want to stick that up into Azure, you can with ADDS. It works just like a sort of a regular domain controller. You can join computers to it. You've got user accounts, all that sort of stuff. Does LDAP and group policy and NTLM and all that sort of stuff, except you don't have to run it locally and Microsoft look after it on your behalf. So this is useful for companies that have apps that use domain authentication, for want of a better word, and don't want to switch to Azure Active Directory or something, which is not compatible with normal Active Directory from an authentication point of view. Then ADDS is something that people can look at and just get it up into the cloud. I think what's interesting here is there's a bunch of people that have Active Directories in the cloud already in Azure. They just host them in virtual machines and then sort of join them to their own, or extend their domain, I guess, for want of a better word, into one of those domain controls in the cloud for, VMs and things that they've got sitting up running in AWS or in Azure. But this sort of gives them a better way or an easier way to create a DC up in the cloud.
Mm-hmm. That's nice. It's nice for companies, for small businesses who don't want to deal with the whole, standing up AD and stuff in their on premises, and want to be able to get the benefits though from Active Directory. This way they can use a pure cloud service now, making life a heck of a lot easier. Really good for those virtual based companies too, where not everybody works in the same office.
Yeah, absolutely. And weirdly enough for us, we do a bunch of work with Active Directory, of course, and at Hyperfish. And I've got 3 or 4 different environments running in Azure, and they've all got Active Directory virtual machines running. And so I'm going to play around with moving this to a ADDS instance instead and seeing how the costs stack up.
Interesting. That'd be cool. You have to come back and let us know how what you think about it and what the cost impacts have been.
Yeah, will do, for sure.
Awesome. Well, hey, I got another bit of, this isn't a GA announcement, but man, we could go back onto the whole price wars and have to see if AWS or Google responds to this one. But at the beginning of October, Microsoft announced some pretty dramatic price reductions around their virtual machine offerings. So they've really broken it down to 3 different areas. So you've got the general purpose VMs. Those are going to be in the D series, the V2 series, DV2 series. So we have the D series and you have DV2s. And the V2s are about 30% more powerful than the Ds are. They've had a price reduction of up to 15%. These DV2s, these are really popular for container workloads, and being able to use those as like a Docker host if you're using for different container workloads you may have. But the other part that was really impressive with this, and this is great for those of you who have an MSDN license and who use virtual machines for, say, your development or for just testing and stuff, those very base level VMs, the A1s and the A2s, the price reduction on those has dropped by almost 50%. So you're going to get twice as much usage out of those based on the Azure credits that you get with, like, say, your MSDN subscription. In November of 2016, Azure is going to release a new series of VMs called the AV2 that are based on the A series. Their pricing is going to be up to 36% lower than the A series standard VM pricing that we have today. The A series, those are like the entry level compute tier. So that's going to also give you some really good price reduction there for using, like, MSDN or something like that. or if you're using your VMs off of MSDN subscription.
Gotcha. Very nice.
Yeah. So you have anything, any other cloudy kind of interesting stuff here that our listeners might be interested in?
I do. One final thing. Facebook are launching Workplace, which is a rebranded Facebook for Work. They're now calling it Workplace, which is basically Facebook's taking on things like Slack, parts of Office 365, tools like that. And so they're launching it. It's come out of preview or beta or whatever they called it. And anybody can go buy it now. So it's basically the Facebook you know and love or hate, and except without all the cat and Trump jokes. So it's in a closed environment for work, obviously. Kind of takes on Slack. You can have different groups and things and conversations. You can do video streaming through it. What's really interesting, though, is their cost structure and their pricing. So they are modeling their pricing based on what they call active users per month, right? So say if you've got 1,000 users in your organization, rather than paying, say, $3 per user per month, you pay $3 per active user per month. And an active user is basically determined by if somebody in the company or if that person in the company uses Facebook Workplace once in a given month, right? So they become an active user. But you only pay for the people that are using it, which is kind of interesting because it's kind of a new take on software subscriptions or SaaS subscriptions, or not a new take, I mean a relatively unique take, I guess. There's not many companies that do this right now. And they're basically saying, hey, rather than paying for all your users, just pay for the ones they're using this and are successful. And then it's up to them to make it look interesting and useful for those people to go use and adopt and get them using it. So I thought that was a pretty interesting take on it. This is, I think, going to be really interesting to see how it affects Office 365 and really interesting to see how it affects Slack. Honestly, I don't think it's a huge problem for Office 365 because it only really tackles a small part of the 365 puzzle. But for Slack, it's kind of much more of a direct competitor in my view.
Yeah, it's a really interesting take on the licensing. And as you say, it definitely, I'm curious to see what kind of an impact it has on all the subscription business, because you can pay for a subscription to something thinking that you may need it, or in the case of your organization, you've got 1,000 users and you need to make sure that everyone has access to, say, SharePoint or Yammer or Slack or whatever, or Facebook for Work, or the different services. It really does from a customer point of view. I find it really interesting because if you already are a user of those services and you are using them, you're paying for a subscription, well, there's really no increased cost for you. But what it does do is it incentivizes the provider. So in this case, Facebook for Work, it incentivizes the provider to make sure that you are using the service. And so it incentivizes them to give them more reason to pack it with features and things that are going to make it useful to you, and not something that somebody's going to buy a subscription for you just in case you need it. I really, really like that model. I mean, from a company perspective, it takes a lot of guts to be able to do that, because that's a lot of extra work. It's really taking the level from licensed software to subscriptions to the next level to, okay, now that you subscribe to it, but we have to make sure you're using it. If you're not using it, then hey, you don't need to be paying for it.
Yeah. The interesting part about that is I don't know if companies are ready to pay for things like that. Companies like predictable costs, and one of the problems with consumption-based pricing models like this, and with things like Azure and AWS, is if you can't predict the price, it's very hard to get people to agree to it, right? So I guess you have to budget for everybody using it and pay less if they don't.
Yeah, but I see what you're saying there, but I think the one thing that would be different though from the AWS or Azure or GCP is that you do have a cap in this case. Like the cap is what you would be paying for if it wasn't in this model and you're just paying for a subscription. So you do have an upper threshold. Of course, if you are going to buy this, you're a purchasing agent, you're going to buy this and you've got 1,000 users, then you're trying to play the game. Well, I'm not really paying for it for 1,000 users. I'm really paying for it for 700 users because 300 of those users won't be active. I get that side of it, but it at least gives you, unlike the cloud stuff, which could have runaway costs, this one at least has at least a cap on it.
Yeah. Yeah, that's definitely, you're right. It's, at least there is that cap. They've got interesting integrations with, G Suite. God, that still cracks me up. That's the Google Apps renamed thingy. Okta, one login, ping identity, Windows Azure AD for single sign-on, all that sort of stuff. So they've definitely thought through. It seems pretty full-featured and ready for companies to start taking a look at. So yeah, that's pretty cool.
Yeah, it is very cool.
Hey, so on to bigger things, I guess. We managed to sit down and do a really interesting interview with Kelsey Hightower about Kubernetes, which is another container, I guess, engine, for want of a better word, or way of running your container-based applications that comes from Google and is kind of gaining a bunch of traction in the market and things. We were very lucky to sit down with Kelsey and talk through Kubernetes, and it's a bit of a explain it like I'm five interview in some ways, or a 101, especially for us. You and I haven't done any Kubernetes work at this point, but it was really interesting to sit down with him and get a take on where Google is at with this, where it came from, how it sort of compares and contrasts to a few other container systems, and get the sort of the lowdown on what Kubernetes is. So what did you think of the interview?
I really like this. I mean, I just add one thing to what you just said is that, I would say Kubernetes is going to fall, and you'll hear this in the interview, but Kubernetes is going to fall in that category of a container orchestrator. And so it's one of those things that is, you can still build Docker containers. It can still host Docker containers. So the fundamental development doesn't really change from like all the other stuff that you and I have talked about in the past with Docker Swarm and Docker Cloud and all that. You can think of this thing as it would compete with things like Mesos. It would compete with things like Swarm, like Docker Cloud. In the sense, it's going to help you go through and have a cluster of machines and just hand it over your container workloads and say, go run these things. When I sat down with Mark Fussell at the Ignite conference and talked to him about Service Fabric from Microsoft, we talked a little bit about this. And I thought something he said was pretty interesting. And that's, when you look at how Microsoft has done stuff in their cloud, they built Service Fabric to run a good portion of Azure. So it was running Azure. There's a lot of things like the Azure SQL Server, Azure Document Database, and a bunch of other Azure services are all built on top of Service Fabric. And then Microsoft basically open sourced Service Fabric and made it so that we can build our own stuff to deploy it, or it can be part of, say, Azure Stack. On the Google side, what Google did is they have their own internal version of Service Fabric that they call Borg that runs all of their stuff. And I thought that not only what Kelsey said in another interview that people will hear in the following episode after this one next week with Brendan Burns, who was one of the original developers of Kubernetes at Google, who now works at Microsoft. I found it interesting that Kubernetes is, I don't want to call it a port, but it's an open source version of Borg. They took the best stuff of Borg and put it into Kubernetes. And then they also took stuff where, I love the way that they describe it as, they said there's no sense in re-implementing bad decisions. So they took stuff that they had learned and they had said, we're not going to do that. So it's another way of doing it. Kubernetes is the thing that runs the container offering from the Google Cloud platform. So it's growing quite a bit in its popularity and interest with a lot of people out there. So we thought we'd sit down and have a chat with Kelsey, who's he's kind of like Microsoft's version of a developer evangelist, but he works for Google and focuses primarily on cloud and Kubernetes.
Gotcha. Nice. Let's why don't we get stuck into it? Let's roll the interview.
Sounds good. Hello, everybody. This is Andrew Connell, and I'm sitting here with Kelsey Hightower, or at least virtually sitting here with Kelsey Hightower, who is a staff developer advocate at Google. So, Kelsey, welcome to the Microsoft Cloud Show.
Hey, thanks for having me.
Absolutely. Absolutely. So CJ and I wanted to bring you to the show here because I'm a follower of your work. I'm following you on Twitter and some of the stuff that you've been doing on GitHub as well that you've been publishing. And in the last couple months, CJ and I have talked a decent bit with our listeners about containers. And more specifically, we've really focused on the Docker side of containers. So our listeners have a bit of an understanding on what containers are all about and how they work and why you would take advantage of them. As we've talked to our listeners, containers are one thing. And once you kind of dive into it and you start to do a real system or real application, you quickly start to find that you have some sort of a need for some sort of an orchestration with containers. I've seen stories about people saying that, we've traded our monolithic application for the problems we have in the monolithic application with now a problem with containers. And like I said, we've talked about Docker. We've actually had Docker on the show one or two times to talk about like their Docker Cloud product. And we've talked a little bit about Swarm for orchestration options, but we know that there's other options out there like Mesos and like Kubernetes. And I wanted to bring you on the show here, or CJ and I wanted to bring you on the show here to talk about Kubernetes and help our listeners understand, or not only understand what Kubernetes is, but what the value it provides, what problem it's trying to solve as it relates to containers and such. So I guess we talked a little bit before with you about Kubernetes, and you had a different kind of way that you like to approach it with our listeners. So I guess before we dive into this whole thing, do you want to introduce yourself and tell our listeners who you are and what you do with Kubernetes, and then just start diving in, just kind of explaining what is this, and we just have a discussion from there?
Yeah. So my background, I'm Kelsey Hightower, currently at Google, and my background, I started out life as a sysadmin, so managing servers, and installing software, managing monitoring, everything that comes in the catch-all of operations. I have a bunch of empathy for people doing that job, so I did that maybe my first 5 or 6 years. And then my latter years were all around development. So I think I have both sides of the fence and a little bit of management experience in between. And I've worked at companies like Puppet Labs, CoreOS, now at Google, focused on Kubernetes. And so my background is one of, all perspectives around the job.
Gotcha. I see. So let's look a little bit at Kubernetes. I mean, when I look at an application that we're building using something like, say, using containers and Docker and such, I'm familiar with Docker Cloud and how it helps me automate the multiple container-based application. And I know that Google has, there's a whole background behind Kubernetes and how it kind of came to be. Can you share a little bit about that with our listeners and where Kubernetes kind of came from and what problem it's trying to solve?
Yeah, so if we stick to the technical part, so there's products which we package up and sell to people as solutions to specific problems that people are having. And then there's the technology and the ideas that go into those products. So I'm going to focus today mainly around the ideas, the projects, and the technology. So if you think about the problem, you have an application that you've built. We've been building these apps for a very long time in very similar ways. They compile down to some form of binary. Maybe you're in a world where it's decoupled with your application bits are decoupled from the runtime, so you need to assemble them back together at deployment. So regardless of what that is, you need to figure out how to get your application to a machine in order for that application to compute and execute. So given that problem, one solution to that problem would be, let's put these things into some image format. So the most popular image format is the Docker image format. So this idea that we take our application, all of its dependencies, and essentially put it in a tarball, right? That's the technical implementation details behind a Docker image, right? So you put everything in a tarball. There's a bit of a config and there's support for layering. So we can make these tarballs a little bit more manageable by referring to other images that have been created in a very similar fashion. So that's about application packaging. And then we want to share those packages. So we push those to a repository. If we step back a little bit, this is very similar to what we were doing with RPMs, Debian files, ISOs on the Windows side, EXEs. This idea that our application needs to be packaged and distributed. So containers, the container image, that part of the application packaging process is kind of a new way of doing things, making things self-contained, very popular, maybe made popular by Heroku. We see this on the mobile devices. You go to an app store, you click on the application, and it pretty much comes down with everything it needs to execute. So we're applying that pattern to the applications that we build on the server side. What Docker brings to the table is a much better workflow for doing so. So that is kind of the improvement there, this idea that we can have a very clean workflow for describing how we want our images to look and having a tool that can also build those images. So that's the first part. And the second part is once you have an application and a way to push it to a single machine, you also need something to start and stop that particular application. So the case of these Docker images, we have our self-contained application, and we would like to run multiple copies of that application. So that means we can do a little bit of optimization there using copy on write file systems. So we can take one copy of that container image, copy it over, and start as many instances of that process that we want. So container images are used to create isolated processes using the facility of the kernel that you're running on. So if you're on Linux, that would be C groups, namespaces, and maybe some things around networking to make sure that your process will be able to communicate with the rest of the cluster. And then the last thing at a high level would be once you have lots of machines running lots of processes, you do need to coordinate and manage them. Which processes can talk to which process, discover where they are, do things like send traffic to them behind a load balancer, configure them, and so forth. So Kubernetes specifically attempts to solve the latter problem. We assume that you're going to package your applications in some form of a container image so we can have a cleaner contract between the application developer and the system that's doing the management of the application. So we don't have to worry about Python, Ruby, and all those things. We can all have a single abstraction, the container. And then once you have multiple nodes, we need some way of managing them across those things and also doing things like using resources effectively, making sure that each machine's resources are utilized properly. We don't want some machine sitting there idle, wasting money inside of our cluster. So Kubernetes also helps with resource isolation. So I'll stop there. And I'm pretty sure that will spawn.
I see. So then are you saying then that, I guess similar to, if I'm trying to draw some analogies here to how some of the other orchestration tools work, is it something that I'm just going to take my application, my container, or like the description of my application and then just hand it over to Kubernetes, and I've already defined like a cluster and stuff in Kubernetes and it knows how to distribute that? Or how does that work? I know that there's another concept of like pods and stuff in there, so I'm not sure really how to start with this.
Yeah, so it depends. If we're doing let's say we're doing product marketing, I would say, yes, you give us your application and we run it and we scale it and we do all those things. And then on the technical side, there's an implementation. The implementation details are where it's interesting to me. So Kubernetes is more of a framework. And the reason why I say framework is that most people are building products on top of Kubernetes. These would be things like OpenShift, GKE, Google's container engine. Huawei has their container engine built and powered by Kubernetes, Deis. There's a few others. So those would be products, things that ship, a distro of Kubernetes and add some features on top or make it a little bit easier to use with some UX bits that are a little bit more user-friendly. The implementation detail is what makes Kubernetes unique. This idea that we have new abstractions to describe what an application deployment looks like. So instead of just saying, here is my container, instead you will say, here is a pod. And a pod is one or more application instances or application containers. So maybe I have one container that's doing TLS termination and rate limiting. Maybe you're using Nginx for that. So that would be a single Nginx container that will run in the same pod as your application. So maybe you've written an application on Ruby on Rails, and that will sit behind Nginx. So the pod allows you to construct that similar to what you would do on a virtual machine. And pods also hold things like volumes and the networking stack that's shared by multiple processes inside of a single pod. So the pod is the lowest level thing that we move around inside of a Kubernetes cluster.
Gotcha. So would that be equivalent to something in Docker? Would that be similar to a compose file, for example, where you're sort of pulling together a series of pieces of your application and services together to, just stand up in a pod?
Not really. So in Docker Compose, you're taking individual. So in Docker, the lowest level unit of compute is a container, right? So this container runs as a single process. If you want that single process to fork off stuff in the background, you can totally do that. But that's not really the use case. And the pod is very deliberate design decision to say, we know that most applications are built from logical parts, right? So my logical web application could be built of, if you think about it, maybe 4 or 5 pieces. Nginx, maybe a local caching service, the app itself. But the user will only see it as one endpoint on the network. They don't know about the implementation details inside. So the pod allows you to do a very similar composition, but they're scheduled in an atomic unit and they will always land on the same machine in the same namespaces and everything will be shared together.
Gotcha.
So,
that's cool.
So a pod then is, I guess what you're saying then is it's like it's an intermediate between the way that we do this and say a completely native Docker scenario where I just go container and then just scale the containers out, where a pod's going to let me group together either dependent pieces or maybe not tightly coupled, but groups of, it's going to be able to put a portion of my application that needs to kind of travel together and share things between each other, but they're going to have a lot of communication. When I scale one, I really want to scale both pieces to both containers that are inside the same pod. But is that an accurate way of looking at it?
That's right. It's the logical application that could never be split. So if you have a part that could scale independently of the rest and still work, then those things should not be in the same pod.
I see. So then could you then take it to the logical extreme then it wouldn't be too far to imagine, say, that I would have one container inside of one pod. I'd have almost a 1-to-1 ratio or 1-to-1 relationship of a container to a pod in certain scenarios where everything was completely isolated from each other and it didn't have any kind of cross dependencies.
Well, yeah. So like sometimes I'll write a Golang application that is self-contained. It has its built-in web server that's pretty scalable. I don't need anything on top. I don't need to have like a sidecar process that goes and pulls some data before the process starts. So if I don't need any of those things, then yeah, most commonly you'll always see one user-defined container per pod to do that. But the trick though is in a pod, there's always another hidden container that you don't control. And we call that the Infern container. So it's the infrastructure container. And what that thing does, it goes and interacts with the container runtime to have, in the case of Docker, it's the first container that gets created. It's the thing that gets the IP address. And, it starts creating the pod. So when we start to add your containers, we can join them to the same network namespace as that first container. So that way we can restart your containers without necessarily losing the network IP address because it's not tied to any user-defined container. So it's almost like having that virtual machine. Your processes run inside of this resource envelope that kind of gives you this execution environment that you can kind of count on always being there.
Let's take this to the people who may not be as familiar with containers then. So if I've built an application, a traditional website, and I'm going to deploy that website, say I want to host it in the cloud. So I've deployed it to a virtual machine. That virtual machine lives in one of the public clouds, but it's really, when I want to scale it, it's really among a cluster of physical boxes that are inside a public cloud where in the Kubernetes, if I'm thinking about this, like drawing the analogy with Kubernetes, I've built my application. It lives in a container. I then, like I would normally put it in a virtual machine, I have it grouped within a pod or multiple components within a pod. And then that pod allows me to be able to scale it to multiple things within a cluster of Kubernetes hosts. They're going to be able to run this pod, but it allows me to be able to recycle the processes or the containers inside of the pods, but not lose all the shared things that have been provisioned for that specific instance.
That's exactly right. And it also in the future gives us so much power that we can actually add a container while the thing is running to the pod. Maybe you want to do some troubleshooting, and there's an administration pod or container that has all your admin tools. You can imagine a world where we take that administration container, join it to a pod at runtime, share it with all the other namespaces so you can actually see the mounts networking of all the other processes, do your troubleshooting, and then pull it back out.
Right? So you could like a troubleshooting container that you almost say, go fire this up inside the pod, and it does a ton of aggregation or collection of a bunch of telemetry, and then shuts itself down once it got everything it needed.
You got it. So now we have this very powerful mechanism to do things with at the logical application. This is why I keep saying logical, because most applications tend to have many moving parts. Most people just don't think of it that way. Like you may have a big data pod that needs to go and like sync down, a terabyte of data before the process can actually start. So we support that with things like volume plugins that can do a little bit of prep work on the pod before we start all the applications.
Interesting. Very interesting.
I was just going to say, so there are a bunch of other tools in this, in the container space, things like Mesos and Marathon and Kronos and, Docker Swarm and all these kinds of things. What's the relationship to some of those? And are there some scenarios where, say, Kubernetes and Mesos would come together, or maybe with Marathon or other tools? Is it just if you're building something with Kubernetes, are you all in on the Kubernetes toolset, or can you make a combination of those things depending on your scenario?
That's a good question. At a high level, they all do the same thing for the most part. This is going to be preferences. This is how humans in the world work, right? No one will ever do the same task the same way across the board. So that's just going to be natural. There's not just one airline, not one TV station. So I think that's just kind of natural.
Yeah.
The things that are slightly different is that Kubernetes is a monolithic, all-encompassing tool with a single API. So some people look at that and say, oh man, I can't stick my thing in there and do whatever I want. The truth is you really can in Kubernetes. Underneath Kubernetes, the container runtime, we abstract it away. So if you want to use Rocket or Docker, that's not a big deal in the Kubernetes world because we attempt to kind of abstract that away and not leak any of those implementation details. And if you look at the other parts of Kubernetes around service discovery, we have an API for service discovery that anything inside of the Kubernetes ecosystem can count on. We don't expose something like console or even etcd even though etcd is running behind the scenes, etcd is subject to change. It has its own API. So in the Kubernetes world, anything we do is built around this idea of a unified API. So we really think long and hard about adding new features, because you have to also define the API that will be used to drive the feature, and not necessarily say, oh, we found Vault for secrets. Let's expose that to all the applications in the cluster. We'll have our own secrets interface that Vault could be an implementation detail of where the secret is stored, but we will never leak that out into your application.
Gotcha. I guess that's kind of nice as well from a dependency point of view, in that having played around in this world a little bit in the Docker space, doing things like service discovery and things like that in the past has been bring your own. And it can be a pain, right? It's you've got dependency problems, you've got compatibility when one version upgrades to another. And so I guess the encapsulation and everything being contained brings a lot of benefits in that regard.
Very much so. I mean, just like in the Unix world where everything's a file, that was a very powerful abstraction to allow us to kind of unify some of our interfaces, make it a little bit easier to interact with the entire system. Kubernetes attempts to do the same thing with a different set of objects that are application specific, and the same benefits apply.
Interesting.
Gotcha. That makes a lot of sense.
So let's say I'm somebody who wants to get started with this. I want to have a play with Kubernetes. What does the story look like? Like, what do I need to run? If I'm doing this stuff with Docker, I know that today they tell everybody to go to the getting started page, download Docker for Mac or Docker for Windows, and you're really off to the races and starting to create your first container. But let's say I've already got some stuff already set up. I've already built a container. How do I then get started and to stand up Kubernetes? Is this something that I do on my laptop? Is this something I really need to go to a public cloud and stand a server up for this? Or what does that story look like?
Okay, so I think the right analogy to make here would be, you wrote an application and you want to get started with Linux, right? So what do you need to do? Linux needs to run somewhere. And once you do get a Linux server, that particular Linux distro is going to have its own interface on how you place your process. Either you're going to SCP it, maybe run it under a systemd unit file. So there's some things to learn. Most people take for granted that they already know Linux so well that it seems like there's nothing to do. You already know what to do. You put your stuff there and it just runs. So in the Kubernetes world, you have your choice. If you want to run on your local laptop, we have a project called MiniCube, which will give you the entire Kubernetes setup in a single kind of binary that will use like your native virtualization technology to create a Linux VM, add all the Kubernetes components to give you that Kubernetes endpoint. You'll also have the Kubernetes command line tool, and you'll be able to interact with a single node Kubernetes cluster. And to be honest, since Kubernetes doesn't really make you decide which specific node to perform actions on, that single local Kubernetes setups will feel like what you see in production. Even if there was 25 servers in production, you still only interact with a single Kubernetes endpoint. So one way to get started as a developer, you do need to learn a few things. You need to learn about pods. We do have a command line tool that makes it really easy. You can say something like kubectl run, the name of my application. So maybe it's nginx, -- image equals nginx, and the tag you've given it. So that will automatically pull it from the Docker Hub, generate all the Kubernetes configurations required, and just run it in any target Kubernetes cluster. So in one line, you can almost do the same things you did with Docker Run, but you'll get the Kubernetes equivalent, which will automatically put your application container inside the cluster and give you all the facilities to expose it maybe through a public load balancer or through what we call a node port if you just want to hit it locally, or even scale it horizontally by using the interfaces that we provide. So as an application developer, you have choice. Laptop, MiniCube, hosted. I don't want to learn how to install Kubernetes. I just want to use it really quick. You can use something like Google's container engine, which is backed by the open source project Kubernetes. Or you can actually find another distribution like Red Hat has OpenShift, CoreOS has Tectonic, the Deis folks have Deis Workflow, and many of those can be considered as a Kubernetes distribution. They'll have everything packaged up nice and neat, and a lot of times they'll add a little bit of sugar on top, maybe a better dashboard for doing things so you don't have to live on the command line, or a full platform as a service so you can kind of interact with Kubernetes like you would Heroku.
I see. So what you're saying then, like the MiniCube, that sounds very much like if I'm doing things with Docker, then I'm going to go get like, say, Docker for Mac or Docker for Windows, where once I install this, it does the whole thing behind the scenes of creating that little Linux distribution and creating and setting up the command line tools so that I can do Docker run without having to go worry about standing up a cluster and all that stuff. It makes it really simple. So it sounds like MiniCube is doing the exact same thing for me on, like, say, on my laptop to be able to give this a shot before I want to try and deploy something if I'm doing things like disconnected in a way.
Yeah, big shout out to Docker there, because a lot of the technology in MiniCube, we basically are using a lot of the Docker stack that they use for Docker for Mac. So very similar. So we actually kind of use the same tooling to get the local hypervisor set up, get everything installed. We just go the extra step to install all the Kubernetes components on top. So in this case, you can actually use the Docker that's bundled in MiniCube to do all your Docker development and then turn around and execute those containers inside of the Kubernetes cluster that's layered on top of it.
Interesting. Is MiniCube OS X, so Mac for Mac, but does it also work for Windows as well?
Linux and Mac for now. But considering that framework that we're using is, consider the framework we're using is from the Docker folks, I'm pretty sure that Windows support will be around the corner.
Gotcha. I gotcha.
Actually, on that topic, this is something that we saw a lot of talk about at Ignite 2016, which was last week, big Microsoft conference, and they talked about the release of Windows Server 2016 went GA and Windows container support. Is that, considering our audience is pretty Microsoft heavy and Windows heavy and things like that, is that something Kubernetes are considering in the future or investing in around Windows containers or being able to run, not just Linux workloads, but Windows workloads in the future? Is that something you guys are looking at?
Yeah, I've seen it work before already.
Wow, very nice.
I think we should, if you're interested, I think there's going to be a live stream at Kubernetes conference called KubeCon here in November. And you'll see some people who are invested heavily in the Microsoft community doing live demos of this actually working in real life. So this is not something we're imagining or possible in the future. It actually works today, mainly thanks to, again, Docker did a good job of cross-OS support. Windows did a great job of adding the kernel facilities to make it straightforward and well-integrated. And as a result, since we have this layered approach in Kubernetes, if the Docker daemon is there and you're using that particular container runtime, then we use the same API interface, which is kind of the power of Docker. And now Kubernetes can actually do things there. There was some work around making sure that networking and volumes work. But the people working on this, I'm not going to give away their surprise here, but they're doing a great job and they know what they're doing. So I think you're going to see some very first-class stuff in that area.
Yeah, I think I've been very impressed with Microsoft's openness to participating in this area. And we interviewed Taylor Brown from the Microsoft team, from the Windows team specifically, who's been working on a ton of this stuff around containers and Windows and things. And for me, it just feels like it's a huge leap for a lot of Microsoft developers that have never participated in the Linux world to make the leap to Docker or to containers or Kubernetes because of that Linux history there. And that this is really sort of the unveiling or the opening of the kimono, so to speak, to those folks to help them sort of make that leap or make that first step to the world of containers. Because I think it's definitely something coming for them. It's just a matter of time, but I think this will make it a lot easier for them.
Yeah, I think honestly, it may not be too new for some of them. If you really think about the foundation of this stuff, like I know in Windows world, it's always been possible to create a self-contained application. I remember clicking some of those MSIs when you double click it, next, it's all installed and it seems to just magically work, especially if it's done the right way. So that's kind of that self-contained application. What we're doing now is introducing a new API, a new way to think about, instead of manually downloading things and moving things around, actually adding an API on top of it. We've seen this across the industry in general. There's APIs to do things like spin up a virtual machine. There's APIs to get a DNS domain name, certificate purchased. So I think everyone in the development world has been used to an API-driven world, even to process a credit card. So why not add an API on how to bundle and deploy an application? So I think that is kind of a natural progression that this particular area of tech had to go through. Now that it's here, I think most developers are saying, great, point me at the API documentation, and I'll see what the API enables me to do. And then their thought process will kick in and start getting really creative.
Yeah, agreed. I think it's amazing, like what's been going on in this space over the last few years too. I mean, just like you said, once we make these kind of advancements, and then seeing how different organizations are really adapting and embracing them and giving new solutions and new capabilities to customers. Another question that I had for you too, we've talked a lot about what Kubernetes is, and we've talked about, what the advantage is or what problems it tries to solve. You mentioned earlier on that one of the ways that you could actually host it was using the Google Cloud Platform, GCP, and their offering of I think it's called GKE, it's Google's container engine, but with a K for Kubernetes. So can you talk a little bit about that? Like what does that bring to the table for you, and how does that simplify things as if you're looking at using Kubernetes?
Yeah, so, Kubernetes, the open source project, we have a group of people around the world, different companies who all collaborate on that. It's part of the CNCF. So it's kind of standards driven. We have a lot of democracy and contributors, community is great. On the commercial side, you'll have a lot of people that say, hey, it's great you have this open source project, but I am not interested at all in building a Kubernetes cluster or managing a Kubernetes cluster, just like email, right? I just want to send email. I do not want to set up an email server first. So what we've done is provide a fully managed Kubernetes stack where we take the open source components. We don't do any trickery here. There isn't an enterprise version of Kubernetes. What we do is provide fully manage all the lifecycle so we can upgrade Kubernetes clusters. We monitor them. We have our operational teams, our SREs at Google, who look after the core components. You can call them for support. And we try to integrate Kubernetes because it's a very extendable system. So any cloud platform you're running on, whether that's Azure, Amazon, or GCP, we can integrate deeply with the facilities there, like load balancing or the logging, or in our case, Stackdriver for monitoring. So we've added all those cloud provider hooks that anyone can use on any platform. We just focus on making sure that you have, our goal is to give you the best Kubernetes experience possible, even if that means modifying our cloud platform to get you there.
I see. So it really just is, I'm just a developer. I like Kubernetes. I like this idea of using containers for building my application, but I don't want to worry about all the stuff of, having to be the infrastructure guy and do all the performance monitoring and all that stuff. I just want to focus on just the DevOps piece of it. So this is Google's offering of saying, we can do that for you as part of a hosted service using Kubernetes. That you can just give us your application and we can host it for you and scale it as needed.
Yep. And I see my colleagues on the sysadmin side doing the same thing, because if you think about system administration, our job isn't just to do deployments and stand up infrastructure. Operation goes beyond that. And I think a lot of people want their time back. So when they go through the list of things that they could be doing with their time, and they say, you know what, I really would like to be focusing on application metrics, performance tuning, monitoring, tracing, logging, all these other things that are involved into managing an application in production. We're in this world now, even if you have like a 4-person startup, people expect your application to work around the world and 24 available. So standing up Kubernetes clusters may not be the best use of your time. So you'll even see this on the sysadmin side, where they'll gain expertise by learning how to do it on their own. But once they've gotten that experience and they feel confident with the system and they know that it's truly portable to another platform, they may just decide to go all in and have it just be managed for them so they can focus higher up the stack.
Yeah, it makes sense. You don't want to have your system admins. There's no value in providing things like password resets and stuff like that. It's like, let's put that kind of self-service in the hands of, automate certain things, put that self-service in the hands of the customers and in the hands of the developers to manage your application the way you best know how to manage it. But let's take care of all the stuff that we can automate and provide cloud scale really take care of for you.
That's right.
Awesome. So I guess we want to go ahead and start wrapping up a little bit here. But I guess for our listeners, what would you tell our listeners if there was a call to action on what they should check out? I mean, I know that I've seen things that you've published, like there's an awesome kind of walkthrough that you have on that we'll put in the show notes for Kubernetes the hard way, and it kind of walks through someone, if you want to stand everything up on your own, here's what you end up having to go through, and you've got it all documented for doing it on the Google Cloud Platform. And it's from the reviews I've seen from people talking about that, saying it's a great way to get a really good understanding of what Kubernetes is, what you can do with it, and what's involved with it, and how these public clouds, how it's going to give you an advantage to somebody else that's going to host this for you, what they have to offer. But what would you say is like a call to action for people who want to check this out? Where would you send them to learn more about this?
Yeah, so I think Kubernetes the hard way is great for people looking to manage a cluster. So I've updated the guide you're referring to include AWS as well. So there's a parallel walkthrough, so you can have it on both platforms.
Awesome.
So I think that's great for people looking to say, hey, I want to manage my own cluster. What's involved with that? So my goal there was to peel back the scripts, give you everything you have to consider, and tell you why we're making those decisions, so you can then take your existing knowledge and map it on top of the Kubernetes requirements. as an application developer, most people have been following all of these patterns that we read about from the various research papers. You go to conferences and people get on stage and talk about how they're managing microservices. And I think what Kubernetes does is give you the patterns to start to express those things in a way that really scales, not just scales in the number of machines, but scales in the developer or the team aspect. We can now start declaratively describing our deployments in a way that there's systematic meaning. We can push these things to repositories, code review them, and then have them automatically run in any cluster that we point them to. So when you start to look at this application-centric infrastructure or cloud native, I think a lot of people have been encapsulating these ideas in the term called cloud native. And when you start to talk about cloud native, which is probably an extension of 12-factor, you start to understand these application design patterns where some of these tools that are popping up, things like service discovery, scheduling, 12-factor application design patterns, you start to see libraries like Spring Boot on the Java side, start to really hone in, you as an application developer, how do you get the most bang for buck in the things that you're building and making sure that they can be deployed anywhere where there's support for these cloud native-like technologies. So I think a lot of people, containers are just the beginning. It really does a great job of solving the packaging of an application, sharing them with anyone that you want to. And then we start to move into a world where I want my application to run anywhere I desire, even if that's multiple data centers around the world. There are now great APIs for doing that. And then that should lead you into the other discussions around the things you need when you start to deal with multiple applications running at larger scales, monitoring, performance, all the things that will help you craft better deployments.
Awesome. I think that's a great introduction to Kubernetes for our listeners as well. So, like I said, first of all, thank you very much for your time, Kelsey, today. Is there anything else that you'd like to just leave our listeners with at the very end here? If there's anything that you'd want to throw out there?
Yeah, I think it's really early. A lot of this stuff is really early. We're in the first couple of years. A lot of times it takes about 5, maybe 10 years before these things become, the standard status quo. But, the only way it gets there is being a part of the community. So if you're looking at this stuff and you're a little bit confused or it feels overwhelming, I would suggest pick any tool, whether it's Kubernetes, Marathon and Mesos, or Docker Swarm. Pick a tool, get involved with that community, and start to drill in and start deriving value from some of those tools instead of sitting on the sidelines waiting for other people to figure it out. I think everyone in the community has some unique perspective to add to help these things mature a lot faster. I'd
agree with that. I think it's been very enjoyable to watch all of these organizations really jumping in and providing their value in this container space. I mean, it's a rapidly growing space. We've seen significant changes from the beginning of the year, this year. So heck, even just over the last 3 or 4 months. So it's been quite a lot of fun. And it's for people who like to learn what's new and what's the cutting edge stuff. This is a great place to be. So thank you very much. I'll make sure that we include links to all the stuff that we discussed in the show notes for the show. Also reference a bunch of other interviews that you've done on other shows, such as the Google Cloud Platform podcast, the Cloudcast, KubeCast, a couple other ones as well, that to give people additional info if they want to go listen in on it. And for our listeners too, make sure you stay tuned, because we're also going to talk to someone over on the Azure side about running Kubernetes inside of Azure as well, and maybe any plans that Microsoft may have in that space too. So definitely stay tuned for next week. So Kelsey, I want to thank you very much for coming on the show and sharing your thoughts on Kubernetes with our listeners today.
Awesome. Thank you.
Thanks very much. Did you like this episode? Please tweet about it and drop us a 5-star review on iTunes. Word of mouth recommendations are the most effective ways for us to grow the show, and we'd really appreciate it. If you have a question for us, go to microsoftcloudshow.com/questions, where you can submit it as text or record it as a WAV or MP3 and provide us a link so we can play your question on the show. Our theme music is an excerpt from Evaporated Eric by Monk Turner, used under Creative Commons. You can subscribe to us on iTunes and the Google Play Store by searching for Microsoft Cloud Show, or via RSS at microsoftcloudshow.com, where you'll also find show notes for each episode. You can also find us on Facebook searching for Microsoft Cloud Show, or on Twitter at MS Cloud Show. And finally, sign up to our mailing list by heading to our website and entering your email to interact with us. Participate in upcoming interviews and other cool stuff. Thanks for listening, and we'll see you next time.